pitch. Holy smokes, he got a hold of that one way back. That ball is gone. That's a big old ding-dong, ding-a-ling, ding-dong, dinger. Holy smokes, he must have hit that ball a mile. But that's impassable. Or is it? How's it going there, sports fans and nerds alike? I'm Clete Callahan, and this is episode 5 of Baseball Physics. That's right, we are discussing whether or not you could actually hit a ball a mile if you are in a vacuum. Can you do it? Well, let's find out. In a vacuum, it might be possible. A mile is 5,280 feet. If we were to convert that into meters, 1,609 meters. So that's going to be our value for X. X equals 1609 meters. What else do we know? We know the acceleration due to gravity is 9.8 meters per second squared. We know that the mass of the ball is 0.145 kilograms. We know that the time of the impact is 0.0007 seconds. We know that the launch angle is 35 degrees. We know that the bat speed is 31.29 meters per second. We know that the pitch speed is 44.66 meters per second. For the sake of our problem, we should assume that the batter makes the best possible contact with the ball. A batter could hit a ball with a launch angle of 30 degrees, the same distance as a different batter that hits the ball at 20 degrees. Yes, I know that that's possible, but that would ultimately change the amount of force from the pitch speed and the bat swing, and let's just not complicate matters, okay? We're also using wooden bats, so our collision efficiency will be 0.2. Okay, so what's our equation? A ball is projected at a 35-degree angle and travels a distance of 1609 meters. What force was the ball hit at? That is essentially what we are trying to figure out. Projected. That is the key word. Since we're working in a vacuum, the only force acting on the ball is gravity pulling it down. The projectile moves in a parabola. It moves in a natural curve. That is, by definition, what a projectile is. Luckily, we have an equation for that. D equals initial velocity squared times the sine times 2 times the angle, all divided by g. But Clete, we know all these variables, are you sure? We have the average exit velocity of the ball from the bat. Okay, but the exit velocity is going to need to be greater if it is going to travel such a far distance. So let's rearrange the equation to find the initial velocity. We Googled how to do this, by the way. We get an initial velocity of 142.74 meters per second. That's about 317 miles an hour. We have to hit the ball with an exit velocity of 317 miles an hour. That is a valuable piece of information. So, how do we hit a ball to achieve such a high exit velocity? Well, do you remember our force problem? I hope you do. F equals m times vf minus m times vi, all divided by t. To find the force, we need the mass, 0.145, the final velocity, 142.72 meters per second. We need to know the initial pitch speed. Now, the pitcher won't throw harder in this scenario. We want to take the MLB pitch and hit it a mile. So let's use the 2019 four-seamer average velocity that we've been using, 44.66 meters per second. The time of impact, 0.0007 seconds. In reality, both the bat and the ball will explode in this scenario. The ball will squish against the bat to where the seams will completely rip off, the cover will burn up, the yarn will explode everywhere, The bat would splinter in a bunch of different little pieces. It'd be like that bird that Randy Johnson hit. It'll just explode, feathers and guts. Are you ready? The force required to hit a ball that hits the proper exit velocity, allowing it to travel for an actual mile, is 38,814.43 newtons. Ho! That is 4 tons of force that you put on that little baseball. Momentum, it's a new vocab word. What is momentum? Momentum is the mass of an object times the velocity with which that object is moving. When I think of the word momentum, I can't help but think of a player colliding at home plate with a catcher. He has the momentum that carries him into that catcher. And we all remember that scene, classic baseball moment where Pete Rose collided with Ray Fosse at the 1970 All-Star game. He almost killed a guy. But what would it take to literally kill somebody by just running into them? It's fun to think about this. Shut up outside, trucks! Trucks have a lot of momentum too. For example, if you were hit by a truck, you would explode most likely, depending on how fast the truck is going. So how hard do you need to run into someone else to kill them? Tune in next week. That's right, ladies and gentlemen. Next week, we're going to find out how to kill somebody by running into them. Don't tell your parents. Thanks for tuning in. Click the subscribe button. Click the thumbs up button. Turn on the notifications. Comment in the comment section. Tell me what you think. Or if you have any other questions, like me on Instagram, Facebook, and Twitter at Cleet Callahan. Watch me play video games, twitch.tv/playbyplay. And we'll see you at the ball game or the classroom, whatever. Goodbye.